Welcome to my lecture series on fluid mechanics 1 and another session which is composed of the numerical recipes or the numericals based on topics that we studied in the earlier lectures. Hello friends, today we are going to solve the link data questions or common data questions asked in the GATE examination. Let us see the case number 1. Here there are two problems using the common data. We have to solve the problem number 1 and problem number 2. The problem goes like this way. The laminar flow takes place between the closely spaced parallel plates as shown in the figure. The velocity profile is given by u is equal to v into y upon h. The gap height h is 5 mm and the space is filled with oil having specific gravity 0.86. The viscosity mu is equal to 2 into 10 raised to minus 4 Newton second per meter square. And the bottom plate is stationary and the top plate moves with the steady velocity v is equal to 5 cm per second. The area of the plate is 0.25 meter square. So using this data, the two problems are asked. That is problem number 1, the rate of rotation of the fluid particle is given by, there are four options are given here. Omega y is equal to 0, omega z is equal to minus y upon 2h. Option B, omega z is equal to 0, omega y is equal to minus y upon 2h. Option C, omega y is equal to y upon h and omega z is equal to y upon h. And D, omega y is equal to 0 and omega z is equal to y upon h. And for problem number 2, there are four options are again. The power required to keep the plate in the steady motion is, option A is 5 into 10 raised to minus 4 watts. Option B is 10 raised to minus 5 watts. Option C is 2.5 into 10 raised to minus 5 watts. And option D is 5 into 10 raised to minus 5 watts. So this is the problem asked in the GATE examination 2004. So let us understand the solution to problem number 1. Here given u is equal to y upon h. So let us understand the solution to the problem. Here given u is equal to y upon h, therefore del u upon del y is equal to v upon h. Okay. Rotational component we'll have to calculate. Rotational component I will elaborate you in the chapter fluid kinematics. At the moment you just remember that is rotational component is the half of the vorticity. So omega z is equal to half of del v upon del x minus del u upon del y, that is equal to 1 upon 2 0 minus y upon h. So that is y upon 2h, and omega y, the rotational component is half of del u upon del z minus del w upon del x is equal to half of 0 minus 0, that is 0. Hence our option is A, which is correct option. Okay, option A is correct option. Then we'll move to problem number 2. The solution goes like this way. We know that shear stress is equal to dynamic viscosity into velocity gradient. So tau is equal to mu into v upon y. So tau is equal to mu, that is 2 into 10 raised to minus 4, which is dynamic viscosity here. V is 0.05 because 5 centimeter per second, so that is 0.05, and the thickness is 5 millimeters, so therefore it is 0.005. So shear stress is equal to 2 into 10 raised to minus 3 Newton per meter square. But tau is equal to F upon A, force upon area. So F is equal to tau into area, that is equal to 2 into 10 raised to minus 3 into 0.25. So therefore F is equal to 5 into 10 raised to minus 4 Newton. So this is the force. Then power is equal to force into final velocity minus initial velocity. Final velocity is given here, that is 0.05 meter per second, and initial velocity is 0. So P is equal to force is 5 into 10 raised to minus 4 into 0.05 minus 0, which is equal to power is equal to 2.5 into 10 raised to minus 5. Hence our option is 2.5 into 10 raised to minus 5. So option C is correct one. Option C is correct one. So this is the solution to this link problem 1. Now we'll take another problem, case number 2, gate for civil engineering. A U-tube manometer is used to measure the pressure of oil in a pipeline which is in excess of atmospheric pressure. The right limb of the manometer contains mercury and is open to the atmosphere. The contact between oil and mercury is in the left limb. Problem number 1. What will be the pressure of oil in the main line if the difference in level of mercury is 15 centimeter? Options are A is 2.943 kilopascal, option B is 22.95 kilopascal, option C is 17.06 kilopascal, and option D is 20.01 kilopascal. Then problem number 2, what will be the new difference in the level of mercury if pressure of oil in pipeline is reduced to 10 kilopascal? Options are A is 2.85 centimeter, option B is 2.42 centimeter, option C is 1.68 centimeter, and option D is 0.78 centimeter. And problem number 3, what will be the difference in level of mercury in the limb of U-tube when the pressure of oil in the pipe is reduced to 10 kilopascals? So options are A is 17.85 centimeter, option B is 13.575 centimeter, option C is 12.15 centimeter, and option D is 9.3 centimeter. So this is the link problem asked in the GATE examination. Now in this problem, the specific gravity of oil is given as -2 and the specific gravity of mercury is 13.6. So we'll go for solution for this particular problem. So this is the arrangement. So here solution to the problem, here h dash is equal to 0.15 meter. So PA by W is equal to 0.15 into -2. Don't change the sign here because specific gravity we have to keep as it is. Minus 0.15 into 13.6 and minus PD by W is equal to 0. But PD by W is exposed to the atmosphere, so we will take here 0 here. So it is equal to 0. So PA by W is equal to 0.15 into 13.6 minus 2, which is equal to 17.069.4, 17,069.4 Newton per meter square. So 17.06 kilonewton per meter square, that is 17.06 kilopascal. So this is the option C. Option C is correct option. So this is our option number C. This which is correct option. Okay. Then case number 2. What he asked in the case number 2? What will be the new difference in the level of mercury if the pressure of oil in pipeline is reduced to 10 kilopascal? And options are given here. So let us understand this particular problem. So from B to F, let us it is depressed or the decrease in of the pressure by X, and there is subsequent rise in X here and X also here in mercury also. So 15 minus X from A to B, and distance between E to C is 15 minus 2X, because 15 minus X that is 15 minus 2X. So due to decrease of pressure of mercury in the left limb will go up, and hence mercury in the right limb will go down by same level as the total volume is constant. So pressure at F is equal to pressure at G. So using as usual PA by W plus 15 minus X into -2. Don't change the sign here once again because it is specific gravity as -2. So we have to keep like this way only. Minus 15 minus 2X into 13.6 minus PD by W is equal to 0. But PD by W is equal to 0, that is exposed to the atmosphere. So this becomes 0. This pressure becomes 0 here. So PA by W is equal to minus 15 minus X upon 100, because centimeter we have to convert in meter, into -2 plus 15 minus 2X upon 100, again we are converting centimeter to meter, into 13.6, which is mercury here, and this is specific gravity of that other liquid, that is -2. So PA is given as 10 kPa, because in first problem it is given as 10 kPa. It is given here 10 kPa. So we'll take 10 kPa here. So 10 kPa, that is 10 into 10 raised to -3 minus 15 minus x upon 100 into minus 2 plus 15 minus 2x upon 100 into 13.6. 10 into 10 raised to 3 is equal to 15 minus 2x upon 100 into 13.6 into 1000 into 9.81 minus 15 minus x upon 100 into minus 2 into 1000 into 9.81, that is rho g here, rho g here, rho g and rho g, specific weight. Okay, so solving this, x is equal to 2.85. See this, whether this figure is matching here or not. So 2.85, let us say, so x is equal to 2.85. So x is equal to 2.85. So option A is the correct option here. Option A is the correct option here. Now go for solution number 3 here. What will be the difference in level of mercury in the leaves of U-tube manometer when the pressure of oil in the pipe is reduced to 10 kilopascal? Okay, so 10 kilopascal if we reduce it, so new difference will be 15 minus 2x. 15 minus 2x, that is 9.3 centimeter. That is 9.3 centimeter. So here the solution is new difference of mercury is equal to 15 minus 2x. When we substitute x is equal to 2.85 meter, we will get 9.3 centimeter. So here option D is the correct option. Option D is the correct option. So these are the solutions to the problem number 1, problem number 2 and problem number 3 asked in the GATE examination. Now we will take another problem asked in the GATE 2004. An inclined manometer shown in the figure below. The reservoir is large. Its surface may assume to be remain at fixed elevation. A is connected to the gas pipeline and the deflection noted on the inclined glass tube is 100 millimeter. Assuming Q is equal to 30 degree, that is inclination is equal to 30 degree, and the manometric fluid as oil with specific gravity as 0.86, and the pressure at A is 43 millimeter of water vacuum, 43 millimeter of water, 86 millimeter of water and 100 millimeter of water. So let us find the solution to this problem. So inclination is given here. Inclined height is 100 millimeter, angle is 30 degree and specific gravity is 0.86. So first of all we'll have to find out the vertical height, that is 100 into sine 30 degree, that is 50 millimeter. Okay, 50 millimeter, but the liquid is 0.86. So H is equal to 0.100 millimeter in terms of water, but it is oil. So 50 into 0.86, that is equal to 43 millimeter of water. So I'll repeat the problem here. So here inclination of height is 100 millimeter, angle is 30 degree, specific gravity is 0.86. So inclination of reservoir is 30 degree and this is 100 millimeter. So therefore 100 into sine 30, that is 50 millimeter. Okay, and but the reservoir contains oil and whose specific gravity is 0.86. So H is equal to 50 into 0.86, that is 43 millimeter of. So B is the correct option. Okay, in this problem the B is the correct option. So option B. So B is correct option. This is the problem asked in the GATE examination. Up till now we have covered two chapters, namely properties of fluids and measurement of pressure. In properties of fluids we covered specific weight, specific volume, specific gravity, mass density, viscosity, dynamic viscosity, kinematic viscosity, compressibility, surface tension, vapor pressure, and its numericals appeared in the university examinations, public examination and in the GATE examinations. Second chapter we studied measurement of pressure, in which we studied the definition of pressure, the units of pressure, Pascal's law. Then we also studied the different types of manometers, simple manometers and differential manometers. We also studied the various mechanical gauges and electronic gauges. Similarly, we also solved some problems appeared in the university examinations, then public examinations and gate examinations. So far, I have completed these two particular chapters, that is namely properties of fluids and measurement of pressure so far. Not only completed in all respect, but some problems will take at a later stage. Now it is high time to start with new chapter, that is hydrostatic pressure, chapter number 3. Again, I appeal to all my students and audience, please comment on the videos, please do like and please subscribe this channel. If you like the contents of this lecture series, please give like and please do comment in the comment box, and please subscribe the channel if you are new to this particular channel. If you like it, thank you. Please cooperate and do subscribe this channel.